Hi, today I want to talk about a research project and deployable app that we created that attempts to solve the traveling tourist problem using data analysis and optimization. So, have you ever felt overwhelmed choosing what to do on your trip? Well, I have, and the traveling tourist problem relates to the issues we face searching for places to travel. Google Map oftentimes recommends the most popular attractions. However, this brings the issue of overcrowding, which often leads to over-commercialized places that take away from the unique and authentic experience of exploring unique locations. Additionally, small businesses are often overlooked, which are rewarding to find and offer unique experiences that help sustain niche markets. So, how do we solve this problem? Well, first, our team decided to use the Torpedo API, which provides datasets and insights about travel locations, tourist attraction data in cities, and numerous other location statistics. By understanding hot zones and hotspots for travel, flagging and highlighting potential tourist traps, as well as finding underground locations, we can combine all of these insights together to create a personalized itinerary for a day of travel. Before we actually begin to analyze the data, let's first understand an important metric used in our analysis, which is polarity. Polarity is a great metric to allow us to understand popular places because it gives us a clear numeric score from 0 to 10. In our Torpedo API that we chose to analyze, each city travel location has a polarity score associated with it. A high polarity score means positive reviews, think words like awesome, fun experience, and great, while lower polarity scores include negative experiences and reviews. This essentially allows us to determine popular locations compared to a normal Google rating of just 1 through 5 stars, which doesn't encompass your entire feelings about a location. To begin our research, we use multiple languages and libraries, the first being Python, which is a foundational programming language to write and execute our entire script and served as an overarching framework to manage the workflow of executing functions and handling data processing in our project. The request library is a simple library for making HTTP requests to web services and APIs to retrieve data, which we use to retrieve information from the Torpedo API and ORS API. These responses are then processed using Pandas. In our code, we use Pandas to load and process the location data we fetch from the API, such as latitude, longitude, and polarity. Lastly, we use the Python library Folium, which is a great tool for visualizing geospatial data and to create interactive maps for each city. So here are various heat maps we generated for 8 different city locations in our API using the heat map plugin in Folium, and this information can then be used later for our itinerary. So, the next step in our solution to the traveling tourist problem is to flag and identify potential tourist traps. So how do we do this? Well, we first found the number of views per month for each of the thousands of locations in each city. Then, we use a variance formula which calculates how much the number of views in a given month compares to each other. A high variance indicates inconsistent popularity, meaning a location may get a lot of attention in peak months, like tourist seasons, but far fewer views at other times. This suggests that the location is only popular during certain times, a characteristic of potential tourist traps. We then flagged the top 5% of places that had the highest review variance and classified them as tourist traps. These figures show how flagged tourist traps are shown on our map. The second to last step is finding underground locations that may go unnoticed. To do this, we needed to hone in on locations that had very small reviews counts, but high polarity, indicating places that are highly appreciated by visitors yet remain relatively unknown. So now let's talk about how we can use preview insights to create a personalized itinerary.
We took four main steps to create our optimal itinerary for the user based on their preferences and the data provided. First, we created a dynamic ranking and scoring system using normalized values. So this includes using the previous methods for finding underground places and tourist sites, normalizing our polarity ratings and number of reviews, and then computing two different scores based on if the user wants the emphasis on popularity or an emphasis on underground places. We also removed tourist traps if the user preferred. Then we truncated the top n locations that will be used to value for the pathing. And then we prepare the data to be used for route optimization. So this includes assigning a latitude and longitude to each location, assigning a weight of how long the user will stay at each location, etc. Then, using the prepared data, we fed this into the ORS optimization API to create an optimized path considering user-defined preferences of the location. So this includes time windows for the user. It also includes the vehicle and mode of transportation. Then, once this is returned to us successfully from the API, we displayed it using a Folium interactive map to the user.